Previous videos we talked about jog frames, we talked about world frame, we talked about tool frames. Now we're going to look at user frames. So user frames are very useful when you have multiple places that you need to be, and maybe if they're angled or rotated in a certain degree, and it makes setting up a lot easier. User frames can be set up in any location with any orientation. So if you remember from previous videos, we talked about the Cartesian coordinate system where we have 0, 0 at the center, and typically when we look at math class we have y positive going up and then x positive going to the right. So we can have that set up in any direction we want, and we're telling the robot where is x, where is y, and where's our origin. So based on that, we could figure out where's positive, where's negative for the x, positive and negative for the y, and positive and negative for the z as well. So we have our world mode here, and then we're going to place our user frame somewhere on this box, which is going to be our workspace. So and then when we actually create this will now tell us how far away from the robot it is. So now this becomes our new origin, and we can place that origin at any space, and that new origin is now 0, 0, 0. So we don't have to constantly figure out how far from the center origin of our robot is to our workpiece. We can make it a corner, we can make it the center. If it's the center of a circle, we can make it to the center of the circle. So it's a very useful tool to have. User frames are in the same area as tool frames. We just have to swap it from tool frame to user frame. And how we set up those frames is the same method we could set up to tool frames. We can use the 3-point method, 4-point method, or if you know exactly placement of where the fixture is, you can do a direct entry. And that's, again, is always the best case scenario, because then it's going to be exact numbers. 3-point and 4-point, you're relying on your eyesight to actually place the point. So you may be off a few millimeters or a few fractions of an inch, which in most cases is not going to be a problem, but when you're doing high production, high accuracy, that starts coming into play when you want to make sure that everything is exactly. So the first thing for the 3-point, which is going to be the easiest way to, if you don't know the numbers, is you're going to record where you want the origin. So that's going to be 0, 0, 0. So 0 in the x, 0 in the y, 0 in the z. Then you're going to go along the x positive axis first, and then you're going to go in the y positive. So then that'll tell us which direction is positive and negative. So 3-point, you go origin, then you go the x direction, then your y direction. For a 4-point method, it's the same thing, but now we can create multiple frames based on the z-axis. We have our 4-point method, first recording point, second recorded point, third recorded point, and then finally, where's the system origin based on that. And then, of course, direct entry, you have to put in the different points of origin, x, y, and z. And we'll do this all in Roboguide. So how we get to the Robo frames is we go menu, number 6, which is setup, frames, and then we have to go to other and find user frames. And then detail will bring us into it, and we can change the method of entry, so whether it's 3-point, 4-point, or direct entry. So here we have set up a scenario much like you would see in an industrial setting where you have maybe multiple different fixtures. One is going to be straight above here, we have one that is angled, and then we have one that is upright and also angled towards the robot, as you can see. So we're going to set up these 3 user frames. So we're going to go first, second, and third, and we're going to make this user frame 2, user frame 3, user frame 4. We're going to do direct entry for our first rectangle, and then we're going to go 3-point for our other 2 rectangles. Now because this is a CAD file, we can easily double click our rectangle and it'll tell us exact sizes. So this is 200 millimeters wide, 400 in length, then it is 350 from the robot's origin. So you can see there's the origin for this type of robot, which is the exact one we have as our certification cart that's in our classroom. So we have 350 millimeters away from that center origin. So we can easily figure out, okay, where's each of these corners and put in the direct method. So let's do a little bit of math and figure out where these corners are. All right, so we know that our rectangle is 200 millimeters by 400 millimeters. We know from our center of our robot down is going to be 350 millimeters in the x direction and 0 in the y direction. So we have x and then we have y. So x positive is down and then y positive is to the right. So if we want to know this location, we just subtract 200 millimeters back. So to the left, because again, to the right for the y is positive. So 200 millimeters, which is half of 400, and then we subtract 100 millimeters, which is half of 200 from this. So we have 250 millimeters by the negative 200, and then if we want to go the opposite way, we're going to add 100. We're still in the negative 200 range for the y, but we're adding 100. And up, we have 250 millimeters. And we have 200, so we went negative to this side and it's positive y on this side. So 200 minus a negative 200 gives us our 400. And then we go down and we have our same amount from here, but just positive. So let's plug in these 4 numbers for our space. Actually, we only need 3 numbers. We need where we want our origin. So we're going to put the origin in the lower left of this, and we're going to make the x direction this way, and then the y direction this way. So we're going to make positive x to the right and positive y forward. So let's go in and let's add the direct method for that point. And we need to figure out how much in the z we need to go down. So we can direct manipulate this end of tool. So we can go in here and I can bring the end of tool down and we can see exact amount we need to be. So I bring this down, and once you get close, it should sometimes snap. Zoom in even closer. And I'm going to do fine tune. So Z positive is down, so I'm going to go all the way down to very fine, and then I'm going to go Z negative, which will bring me up. And we get so that the point is right at that end, and we see what the number is. So I'm going to hit escape out of shift, and then I'm going to go into position, X, Y, and Z, and I'm going to look at the Z point. So right now it's negative 319.994, so what I'm going to do is I'm going to just go negative 320, and then I'm going to go move to, and that's going to get me really close. So actually that's fairly close to the actual object without being a bunch of decimal numbers here. So let's just remember that number. So I'm going to write that down, negative 320 for our Z portion. So what we're going to do now is we're going to find our origin by direct method. So I'm going to close out of that. We're going to go to menu, number 6, setup, frames. We're going to go to other because right now we're in tool frame, other, user frame. So here's our user frame. Now I usually don't set up user frame 1 because I like to use that for our world mode. So I go right to user frame number 2. So I'm going to go arrow down and I'm going to go to detail. So now we're in user frame 2. Let's give it a name. So I'm going to just double click that, keyboard, and I'm going to call this blue rectangle. Blue rectangle, exit. So now we have it as blue rectangle. Let's go to method and let's go direct entry. And you'll notice that nothing happens because this is the actual direct entry window. So let's put in the coordinate for the origin that we want it to be. So we're going to make it this corner right here. So that was 250. So we're going to type in 250, enter. Our y coordinate is going to be negative 200, enter. The z is going to be that negative 320, enter. And then here's our rotation. So you'll notice that our rotation for here is positive x is in this direction and negative or positive y is in this direction. I want the x to be in this direction, not in this direction. So we actually want to rotate this 90 degrees. So we can easily do that in position, and that will be joint 6. We're going to rotate 90. There we go. So now positive x is going to be along this axis, and then positive y is going to be on this axis. So we want to change that rotation here, right here, to 90. Okay, the next thing we want to look at is we want to look at the x, y, and z here. You'll notice that our w is negative 180. That is the rotation to make sure that our end of arm tooling is directly up and down. So we want to change our W to 180. And then we have our direct entry for our blue rectangle. So if I go to previous, and right now our active tool frame is 0, let's turn active tool frame as number 2. So we're going to go set IND, enter frame, 2, enter. So now our active tool frame is number 2, and notice how everything is based off of this corner now. So now if I move this down, I can move this down to, right now it's 3.9, 0, and then if I go X direction, it's right here, and then the Y direction is right here. So now I can base everything off of that corner, which makes things a lot easier when you're working with objects that are angled like this, or objects that are angled and rotated like this. So when we switch back to user frame 1, so we go set IND 1, enter. So now we're back on number 1, and then we're going to set our angle device. So we're going to make the lower left here our 0, 0, 0. So what I'm going to do is I'm going to bring my robot arm over there, but first I'm going to bring this so that the Z is the correct height, -320. Alright, so we're going to rotate this to make it a little bit easier. So I'm going to double click this and see what rotation we're at. So if you see R is -45 degrees, so I'm going to close this out, and I'm going to click my tool end. There we go. And we're going to change our rotation of our tool head to 45, and that will make it so that the X is in this direction and the Y is positive Y is in this direction. That just makes things a little bit easier to move into position. So let's set the center point. So let's go into the corner here, and it's 106, -366. So I'm going to write that down. And let's set this so it's in the center right away. So don't move this. If you do, just hit undo. Click the little blue or little green ball at the end so that you see the red, blue, and green UCS. And let's set that number. So X is going to be the 106, and the Y is going to be the -366. So if I go move 2, now we're in that center position, which makes things a lot easier because this is a 200 by 200 square. So what I'm going to do is I'm going to go right to the origin. So I'm going to bring it all the way to the edge, and notice how it snaps. It's a very nice feature. You'll also notice that it says -100. Then I'm going to bring it in, and we should go another 100. So it snaps right into that corner. So it's a very nice feature that you have in CAD space rather than actual real life. So you can get very precise with this. So I'm going to close this out. We're going to go to user frame number 3, and we're going to go to detail. Let's name this. So let's go here, options keyboard, and we're going to call this red rectangle. And we're going to go down to method. We're going to use the 3-point method. So we're going to go 3-point. So there we go. We have our red rectangle. Let's rotate down. So the origin, we're at the origin. So all we're going to do is we're going to hit Shift, record. So it says you have to have Shift, so I must not press Shift. So click Shift, record. So now it says recorded. So then I'm going to go down to the next position. Turn off Shift there so you don't jump to the end. So we're going to go to the X point. So now what I'm going to do is I'm going to click here, and if you have an actual robot, you would jog it along the X axis to your opposite corner. And I'm going to go Shift, record. So now that's recorded. Now I can also move back too. So for example, I want to go back to that origin, so go down the Y position. So I can go up here, and then I can go move to, and it's going to move exactly to that position. Now it's moving very fine right now, so it's moving actually pretty slow. There we go. So now I'm at my origin. So I'm going to click my Y direction, and now I'm going to scroll along that Y direction. There we go. Now we're at that 200, and we're going to go Shift, record, and now we are new position recorded. So now we have our X, Y, and Z for that portion. So let's go previous, turn off Shift, previous, and let's turn on that user frame. So let's go set IND, user frame number 3, and now you see that we are all based off of that corner. So here's my X coordinate based off that corner, and now my Y coordinate and my Z positive is down, and then our Z negative is up. Now we can change that so that it's the opposite direction if we wanted to, if we do the 4-point method. Alright, so let's go back to that 0, number 1, so set IND 1, and then let's go into this corner right here. So what I'm going to do is I'm going to bring this back to the home position. So I'm going to go joint, and I'm going to go zeros across the board and set joint 5, 0, 0, 0, 0. Let's change this to -90, and now we're back at that home position. So I'm going to rotate this around 90 degrees. So I'm going to go 90. So we're back at this point. Now you'll notice that this is rotated, so we want this to be directly up above. So let's check out the rotation. So if I double click this, we are rotated 45 degrees. So we need to match that 45 degrees. So I'm going to hit OK. And we're going to rotate our joint 5 so that we are 45 degrees, not 90. So I'm going to go -45. There we go. So now we are matching that rotation. Let's look at what our direction of our UCS is. So we have X positive and Y positive. Let's make this corner right here origin, and let's go along the X direction and Y direction above there. So let's rotate this around so that we have the correct direction. There we go. So we have X positive to the left and then Y positive above. All right, so let's bring this down to the corner or get close here, and then we'll zoom in as we need. All right, so I'm going to go to my front view here, and then I'm going to bring this down, and I'm going to do some fine-tune movements since it doesn't let me go. So very fine. I'm going to hold shift, and then I'm going to go Z positive, and I'm going to keep going until I get to that point. There we go. And then I'm going to bring it down in the Y direction. And once again, I'm going to Y negative here, shift down. There we go. So we have it in the corner, but we may not have it in the corner in the X direction. So let's look at it from the top view here. And there you go. You can see we're not directly on there. So let's go in, zoom in really close. And sometimes when you get to the corner, sometimes it snaps, sometimes you have to go very fine. So I have it actually so it snaps. So now we're in the lower corner, which makes things a lot easier now. So let's go setup number 4. So let's go detail, and let's call this green rectangle. So let's go to our double click, options, keyboard, and I'm going to call this green rectangle. Exit. So we're going to go method, we're going to go 3-point, and I'm going to go down to origin, and we're going to hold shift, record. So now we're recorded. Let's go along the X direction. So we're going to shift down here. Oops, had shift down again. So we're going to go X direction. So we're going all the way to the corner, which should be 300. There we go. And I'm going to go shift, record. Now I'm going to move back to that origin. So I'm going to click origin, and I'm going to go move to, and it will move automatically to origin. So bring up the speed here. There we go. And we'll go back down to the Y position, and now I'm going to go up that 200. There we go. And now we go record. So I'm going to go shift, record. There we go. New position calculated. So now everything's going to be based off of there. So I go previous and turn off shift, previous, and I can make that active. So I'm going to go to frame number 4. Now we're active, and now everything is based off of that frame. So everywhere I go is going to be based off of that X, Y, and Z portion of that frame. So now we have all 3 set up. So I'm going to go back to user frame number 1, and I'm going to set that as my active frame, and now everything's based off of that coordinate system. Okay, so that's setting up user frames. Later on we will use that to write programs and make it a little bit easier for us to write those programs.